Hello everyone, welcome back to the Math 0332 playlist on Mr. Lee's YouTube channel. I'm Mr. Lee, hello. We're picking back up. We had just learned about the product and quotient rule in the last video, but we hadn't seen any quotient rule problems that had ended up with negative exponents. So we're gonna see how we deal with that. I think my best explanation for how we deal with negative exponents is either using clever multiplication or talk about kind of exponents like they're money, like it's debt. So regardless of where you see a negative exponent, there's always a struggle between your numerator and your denominator in a fraction. And even though you don't necessarily see a fraction, any number can be written as a fraction over 1. So when you have x to the negative fourth power, which can be written as x to the negative fourth power over 1, it is in a losing battle with the denominator. Basically, how many x's does the numerator have? Negative 4. And what that really means is that the numerator is in debt 4 x's to the denominator. The way we can deal with this is cleverly multiplying by ones, but if I multiply the numerator by x to the fourth, I multiply the denominator by x to the fourth also. And if we add our exponents using the product rule, negative 4 plus 4 is 0. 1 times anything is itself. So any x to the 0th is 1, because anything to the 0 power is 1. And then you have an x to the 4th in the denominator. So what really happened to my negative exponent? It went to the other side of the fraction and became positive. That's why I like to talk about it like it's debt. If you have a negative exponent in the numerator, it's how many x's the denominator is owed by the numerator when you're going to transfer it. Similarly, if the denominator had a negative exponent, it will get transferred back to the numerator, simply because it's like debt. When you're paying your friend back, now they have positive money and you're left with nothing. So when they say divide the monomials and rewrite, you can always subtract just like you did with the quotient rule previously, but then you'll have to move it around if you end up with a negative. Coefficients can still be negative. You are not going to move a negative coefficient. You will only move a negative term that has a negative exponent. Never move a negative coefficient to the other side. That will be whatever it will be, and there will be no movement of the numbers themselves. So y to the 7th divided by y to the 11th. We know from this, 7 minus 11 will end up being negative 4. However, this is a negative exponent. So to rewrite it with a positive exponent, this is really y to the negative 4th over 1. But the numerator owes 4 y's to the denominator because it has negative $4 in its y bank account. So it is really 1 over y to the positive 4th. So you notice when the transfer happens, the number stays the same, just the sign changes. One interesting thing to note is that for some reason you didn't want a fraction, you can always take positive exponents as well and move them to the other side, but it's like accruing a debt. It'd be like the numerator borrowing 4 y's from the denominator, so to recognize that the 4 y's it has are owed to someone else, you call it a negative. That's not really what's happening, but for many people that resonates a little bit better with them as a concept. When you have coefficients, though, you treat them separately just like you have been. So we'll have 75 over 25, and then times y to the 4 minus 13th power. This is 3, y to the negative 9th when we subtract. The 3 will stay. This is really like 3 over 1 times y to the negative 9th. What will really happen is when the y goes to the other part of the fraction, it's kind of also over 1, the 3 does not move. The coefficient stays wherever it is. So that means that the 3 will stay in the numerator, only the y will transfer to the other side, and this will end up being 3 over y to the 9th power. If you can do it with one variable, can you do it with more? Of course. 60 divided by negative 10. When we subtract here, it'll be j to the 6 minus 3rd power, k to the 9 minus 14th power. 60 over negative 10 is negative 6. 6 minus 3 here is 3. 9 minus 14 is negative 5. Now again, j is positive, so it doesn't need to move. A coefficient never needs to move, but this k to the negative fifth, this is our negative exponent, so this would not be accepted. The only one that needs to move here to the other side is k. So negative 6 and j cubed will stay in the numerator, because this is really all over 1 right now, but the k to the negative fifth, you owe 5 k's to the other side, so you better move it there. Give them their money. They want it now. Now, all of the ones we've seen up to this point, the numerator was larger than the denominator. That's not always true. If your numerator is smaller than your denominator, your goal is instead to reduce. And if something starts with a negative exponent, that's okay. You're only really worried about it at the end. So we have 5 over 25, and then by the same strategy, n to the ninth divided by n to the negative third is 9 minus negative 3. A minus and negative is really a positive. So 5 over 25 reduces to 1/5, and this is n to the 12th power. This can also be written as n to the 12th over 5. These two mean the same thing. 9 is very similar to a combination of 7 and 8, so I want to leave that one for you to do. We'll go ahead and knock out number 10. Just to see, negative 18 over 6 times a to the 5 minus negative 2 times b to the negative 6 minus 5, numerator minus denominator, times c to the 4 minus 4. So negative 18 over 6 is negative 3. 5 minus negative 2 is 7. Negative 6 minus 5 should be negative 11. And 4 minus 4 is 0. Now that we know anything to the 0th power is 1, so it's going to go away. But the one thing we have to make sure to do is move this b. So this is negative 3a to the 7th over b to the 11th. So these are some slightly more complicated problems. So this is our second rule that you'll see on the 4th in homework, and as well combined with others on the 6th homework. Now our last rule is the power rule, and that's when you take a power and you raise it to another power. And you can see with this repeated multiplication, what does something to the 4th mean? It means you're multiplying by itself 4 times. And if you write it out, you'll see the total number of x's you would have in this situation is 8. So what do you know about 2 and 4 to make 8? 2 times 4 is 8. So when you have a power and you raise it to another power, you take those two powers and you multiply them together. So I just want to do 1, 2, and 3 on this video. 4 is a little bit more complicated, and it kind of goes with the problems on the next page, which you'll see in the last homework in particular. So x to the 8th to the 4th power, power to a power, you end up taking those two powers and you multiply them together. So 8 times 4 is 32. So this is equal to x to the 32nd power. If they only want you to write it into positive exponents, we'll see. I won't care so much. Y to the 5th to the negative 6. It doesn't matter if one of your powers is negative. You'll still take the two powers and you'll multiply them together. 5 times negative 6 is negative 30. So this is really y to the negative 30th. If they require you to write it with only positive exponents, remember that means you've got the numerator owes the denominator 30y. So once he's paid off his debts, it will look like 1 over y to the 30th. And sometimes when things are nice, the negatives will take care of each other. So you have a negative to a negative. What do you remember about a negative number times another negative number? That's the real question. Remember, negative times negative is positive. So sometimes it works out nicely for you. So really, there start to be ones in this section that are combinations of skills. And primarily the 6th homework is entirely combinations of skills. So we'll do number 4 and some of the examples on the next page and the last page of notes in the next video.